guys, this is the 7th video and we are going to do the new section in this chapter, and just like we did with the first section, we're gonna divide this into two sections so that you can digest it a little bit better. So we'll do complex fraction again tomorrow, and today we're just gonna learn about how to find least common multiples, and also how we can use that to add and subtract the rational expressions. Okay, so let's review how to find the least common multiples, otherwise we write it as LCM, of the regular numbers. So easiest way to do this is actually writing a factor tree. So 12 is 4 times 3. And then 4 is 2 times 2. So I will rewrite 12 as 2 squared times 3. And then 30 is 3 times 10. And 10 is 2 times 5. So I'm going to write 2 times 3 times 5. So to find LCM, what you do is that you write all the numbers that you see. 2 times, 3 times, and I see 5 as well for 30. So I write 2 times 3 times 5. And then you look at the power. And you're going for the highest power. So 2 squared, 3, 1, 5, 1. Because none of the other numbers have a power greater than 1. And so your LCM is 4 times 5 times 3. So 60. 60. Okay. And we use the same principle even when we are dealing with polynomials. And even the numbers, the regular numbers have a factor tree and you find the prime numbers, right? Polynomials, we write factors, okay? So you need to factor first. So this one, two numbers that multiplies to 2 but adds to negative 3. So it factors into x minus 1 times x minus 2. I'm just going to assume that you are familiar with factoring. It might take for you to factor a little longer than I do, but I'm not going to explain every single step how I factored, okay? Because you really need to be working on your factoring skill and you need to be comfortable with that. So this one, I need to do GCF first. So 2 x squared minus 1. And you might be like, okay, I'm done. And this one is one of those special ones that you have to know, which is a squared minus b squared. So I can actually factor further to x minus 1 and x plus 1. And just like the numbers, what you do is that for LCM, you write everything that you see once, and then you look at the power. So I see x minus 1, x minus 2, and I see 2 here. So I'm going to write it in front. And then I see x plus 1 because I already wrote x minus 1. And that's your LCM. And you don't need to FOIL to figure out what the standard form looks like, because we'll never need to do that in this chapter. Okay, so just leave the LCM the way it is. So then, how can we find LCM of 3 things? It's the same as what we did with the 2 things. It's just that it's going to take a little longer because we need to now look at 3 different things. So for this one, since A, B, C are simple, we can just look at it. We know how many A's there are, B's there are, C there are. But the number part, we do need to write a little factor tree to figure out how we can write down the prime numbers. So again, we've seen 12. It's 2 squared times 3, a squared b. That's the first number. 15 is just 3 times 5. So 3 times 5, a, b, c. And then lastly, this one, 8 is 2 cubed, right? So it's 2 cubed, b cubed, c 4. So LCM, again, we write everything that we see. I see 2, I see 3, I see 5. I'm just skipping over to write the numbers first. I see A, B, and C. Now we look at the power. So what's the highest power for 2? 2 cubed. So write cube. Highest power for 3? 1. Highest power for 5? 1. Highest power for A is square, B cube, and C fourth. So let me simplify the number because the variables, there is nothing you can do. But this is 8 times 5, which is 40, times 3, so 120. A squared, B cubed, C to the fourth is the LCM for these three expressions. Let's look at the ones that we need to factor. Again, before you factor, always check if there is a greatest common factor, because that will help your factoring and it will make things a little bit simpler. So I see that they have 4s in common. Okay. Then I factor the trinomials that you see there. So it's 4, two numbers that multiplies to -4 but adds to -3 would be this pair. And then this has a GCF of A, so let me get that out first. Two numbers that multiplies to 20 but adds to -9 is -5 and -4. Okay, so I know with enough time that you can factor this on your own. So if I'm going fast, it's because I have a limited amount of time. Okay, all right. Again, we write everything we see once. First, I see 4a, and I see a minus 4, a plus 1, and a minus 5, and none of them has a power on this factor, so that's my LCM. Okay. So why do we find LCM? When do we use LCM? If you think about adding two fractions, I'm going to show you a regular number, like 1/2 plus 2/3. You have to find LCM of 2 and a 3, so you have to find LCM of denominator to make a common denominator, right? So basically, the LCM would be 6, and then when you make a common denominator, what you do is that you multiply what's missing. So 2 is missing 3 to make it 6, so then I multiply 3 on top, and then for 3, it's missing 2, so I multiply 2 on top, and then now that the denominator is the same, you can just add the tops together and you get the answer, right? So same exact principle, it's just that you have variables now. So let's look at making a common denominator first by finding out our LCM. 5 is a prime number, so it's already done. 10 is 2 times 5. So the LCM of this is 2 times 5 times A times B, except A is a power of cube, and then B has a power of 2. Now, what you need to do is that you have to figure out what was this denominator missing to be like this common denominator that you see right now. Well, it has everything except 2. So that means I had to multiply 2 on top and the bottom to make it look like 2 times 5 times a cubed times b squared. So I multiply 2 on top. Okay. Let's look at the next one. 10ab, well, 10 is 2 times 5, so it has a 2, it has a 5. It has a, but not enough a, right? So I probably need to multiply a squared to make it a cubed. And I still need another b to make it b squared. So I'm multiplying a squared times b on the denominator and the numerator. My nose is itchy. So then this is what's happening. So let me simplify a little bit. The bottom will be 10 a cubed b squared, and top is a 8. 9, and we tend to write it in order, so I'm just going to rearrange and write a squared b and c. Okay, and that's all it is. So let's try this. Again, we need to figure out LCM first for the denominator, so we can make a common denominator. 16 is 4 squared, or 2 to the 4th power, right? So the common denominator will be 2 times 5, a times b, and let's look at the power. Highest power will be 4 for 2. A is cube and b is square. Alright, that's the common denominator, and now let's look at what is the first fraction missing to look like this common denominator. So it has 2 to the 4th power, but it's missing 5 and it's missing a cube. So that means I had to multiply that to both the numerator and the denominator. So I do 3a squared times 5a cubed minus, because it's minus here. And to 8x, what do we need to multiply? Well, it has 5, but it doesn't have 2 to the 4th power. And it has a cube, but it's missing 1b, right? So let's simplify. 16 times 5, I think, is 80. And then 3 times 5 is 15. A to the 5th power, right? Because a squared times a cubed. I have 5 a's now. Minus 16 times 8. I don't think I can do that in my head. Maybe I can. 16 times 5 was 80. And no. Sorry. 8 times 16. 128. I should have known. And then b, and then x, right? Because there's nothing else you can do about the variable. So that's the answer, even though it looks very messy. Okay? And what do you do when you have a polynomials, not just those monomial expressions? Well, first step is just like how we found LCM. We need to first factor. So this one is x minus 3 and x plus 2. And this one, I need to factor out GCF, which is 5, x plus 2. And that's all it is. So then, the common denominator for these two would be 5 times x plus 2 and x minus 3. And you will see that I tend to write a number in front to make it less confusing. And polynomials are actually easier to make what is missing because look, the only thing that this is missing is 5. So I multiply 5 to x minus 1. Minus, because it's minus here, 4, what is this fraction missing? Just x minus 3. So to finish it off, we just simplify the top. 5x minus 5 minus 4x plus 12 over, and I don't care if you don't FOIL the bottom because it's going to be always a little bit messier than the top, the numerator. And so the final answer is 1x plus 7 over 5x plus 2 and x minus 3. Okay, last one of the day. All right, so this factoring is a little more complicated factoring. I think this is how you factor. If you don't remember how to factor this, just review the either box method or the grouping method. And this one is x plus 3 because, 4x plus 1, because the GCF is 3. Again, my common denominator is 3 times 4x plus 1 times x plus 5, and you can tell from the first fraction, it's missing 3. And then from the second fraction, it's missing x plus 5. And so we just distribute the top, not the bottom. So 3x minus 24 plus 6x plus 30. The bottom would be just that big expression. And when we simplify all that, it's 9x plus 6 over 4x plus 1 and x plus 5. But we are not done because this one has a GCF of 3 So actually these 3's cancel, and the answer is 3x plus 2 over 4x plus 1 times x plus 5.